Good evening all. Today we are starting with next problems on isometric views. So yesterday I hope you have watched previous two lectures. This is the third lecture on isometric views. So here you can see a one problem statement, that's front view and the top view. This is a front view, this is top view. So now with this we will start first today's session, first problem of isometric views. So in this question the front and the top view is given. So if you look, total dimension of this question given in front and the top view. So the total length, total width and the total height of the object. So for that I have drawn a reference box of length, width and height. So just look at the question. So if you observe the question, for this question it is clearly given. This is front view, of course, front and top view, first angle method. So this represents front view. So total length it is given 110. Total height is 60 and the total width is given 60. So 100, 60 and 60. So as clearly given, I have taken this as origin reference here, where it is given in the question here. This is the origin point over here. So this is 110. So I have taken 110 on this side. Okay, so that's a given origin in the question here. This is this point. Now, or this same can be given here. So on this side, origin, this side we have length. So there I have marked this 30-degree angle. This line is 110. There it is width as 60. So 110 length here, 60 here, height 60. So 60, 60. So this is the first isometric box I have constructed with this dimension. So if you observe the question, it is having one plate as a base. If you see only front view, it is having base plate here. Just consider this. And that base plate, there is some portion, extruded portion, and that is what it is a, if you take a projection, if you observe, that's a 30 mm square block. So it's a square. So what is this? So we have a base plate on which we have one square structure. There is no surface here. So if you observe, what is this line? This solid line represents this inclined surface. So this dimension is 15 by 15. So we have this is called as a tapered surface or a chamfer. So this is 15 by 15 across a width. So this is a width. So it is cut 15, 15 like this. Now we have one more surface in the top view, which is like a rectangular block of 40 by 20. The location is given 20 mm from one end, means this is 20 and the dimension is 40 by 20. Height of the place is again 20. Interesting part is, if you see only top view, you will see there are two, one is square, one is rectangle, but this square is extruded, it is placed on it, so it's the addition of the two surface, whereas this rectangular block is cut because in front view that is a hidden line, so which is extended for this. So let's draw this object. I hope now you are with me with the introduction part of this question. So we have a base plate, one square structure, one rectangular structure and one chamfer here, but this is a depth, this is addition. So I will say this is subtraction of two surface, addition, and this tapered, or that's technically we call it a chamfer, given at the end. So let's start. So for this I have drawn this block of dimension 110 by 60 by 60. So length here, origin this side, length mark here. On this side I have marked width and height is vertical. So this vertical height is marked as it is, which is 60, 60, 60, and join with the parallel lines. As I don't have any other instrument with me, I'm just using a scale to draw parallel lines, but you try with your instrument, try to understand the concept. Now, first I'll mark this base plate of 20. So let's take 20 mm distance. So I'll take this 20 here, height 20. Same you mark here. If you have like a drafter and roll and draw, you can do it very fastly, quickly, and with the least error. So mark the 20 mm height to draw this plate. Actually, you need not to mark so many points if you have a drafter. You just to mark anywhere and use a drafter to draw parallel lines. Now I am here ensuring exact 20 on all the sides. If lines are not exactly parallel, then it may create a problem. It may look something exaggerated or shrink effect for the object. Okay, so I have drawn this L plate. I'll complete a complete L. Sorry, not L, it's a base plate, of course. So now I'm drawing a reference line for your understanding from this corner also, very thin line. Now I'm completing this structure as a base, and here also. Okay, so let's done. So on this block I have drawn base plate of dimension 20 by 110 and the width is 60 as it is. So covered with all the dimension here, complete plate. Now let's start with first this part, that is how it is located. So locating correct plane is important. So for while I'll just erase few lines. So on this surface plane of 20 mm height, I am finding out the center to locate a plane. So if you read question, from this end this distance is 10 and this is not given, so it is ideally it's symmetric. So the total is 60. So at the center means of course 15 from this, 15 from this, because the dimension is 30. So first locate the center on this surface. So I'll show you, this is a 60. So if this is 60, I'll find out the center of this. As it is not exactly parallel, so it may be a, here is also center. Small thin lines. So finding out the width center. So total is width 60, so center 30. Now from this line I need to take 10 mm. This distance is 10 mm, right? So this line is 10 mm. I need to draw a square here with 10 mm here and 15 and 15 from both, because the square is 30. So these dimension are 30, 30, 30. Total is 60. So this should be how much? 50. So this should be 50. Now I'll mark this 10 and this 15, right? Total is 25 because the total is 30 by 30 square. So I'll just use now smaller scale. So you see here clearly (10 + 15). I am locating center of the square first. Then parallel to these lines, isometric axis is draw all the lines, and then you mark the distances. So now from the center you mark the 30 mm square. So from center I am taking 15, 15 on all the sides, and then draw the parallel lines and join it. So that's all sides 15, 15. This 15, this 15. Now parallel to these lines, always I am drawing a isometric lines, means parallel to this or these lines. Okay, always. So draw one more line here passing through this line, similarly passing to this line. Okay, Similarly, passing to this line parallel to the one isometric axis, draw one more line. Similarly here, draw one more line. So this, I have created a square on this plane of height 20 mm. Okay, so to make it little bit visible for you, I'll draw one more line on it. First, locate a correct center with the given dimension. This is 10 and this would be 15, 15, and this is 30, so total 60. Now, but actually we don't have to create a, means we have the surface which is of given height. You can see it's total 60, this is 20, so of course this will be 40. So from there I'm considering, now I'm drawing the square here right now on this plane. So draw this 40. So I hope it is visible. So now draw 40 mm height to this. Now extrude it on the solid part. How? From all the four corners, mark the vertical height, as height is always vertical. So I am drawing four vertical lines of 40 mm height, exactly vertical. If error, then it would not look like exactly a three-dimensional drawing. So I am trying my best. I have drawn all the four lines. I'll erase few of the lines which are not required at all, because this is a basic line which we follow. For reference again, once you have a good practice, you will understand. Now, what I did, constructed base, locating the square correctly. Now mark the height on all corners. So height is 40. So I'll take 40 mm distance in compass, because height of this block is 40. Take 40. So mark 40 from all the corners and join it. It will look exact. Again, this is one more corner. Mark here 40. So I'll extend this line. Okay, so these are 4 points of the same square which is of this location. Means this, I have drawn this, now transferred to this 40 mm on the surface. Again, join all the points automatically are parallel to the previous isometric axes. So yes, that's a base plate with the square extruded of height 40. From this 40, total 20 plus 40, 60. So guys, now you can erase. This is a basic box I have drawn. So if you observe from this, you can see this edge is not visible. Again, the looking from this edges are also not visible. So I'll make it little bit thin, so that you can visualize the surface. So let's make lines few visible. Alright, so that's this part. Next, first, so we are done with this part, first surface, second cylinder, sorry, a square extruded portion, not cylinder. Third one is, you can say this portion, how it is chamfered. It's very simple. You can see this dimension is not given here, it is given here, that is 15. And what is this dimension? It is 15. So that's given in top view. So this 2 dimension of this lot is 15 by 15. Okay, so how to locate? Of course, it is a symmetric object. So total is 60. Find out for center and then locate it. So I'll say from this corner, the end is 15 here as well as 15 here, similar here. So from this corner points, locate 15 mm on both sides. So from this take 15 From this corner take 15. Same from this corner take 15 on both the sides. So this is also 15. This is also 15. Yes, now join it. Only the line which are inclined, they are called as a non-isometric line, because these lines are not parallel to any isometric axis, that is OX, OY or OZ. That's it. Otherwise, rest of all the lines are parallel to OX, OY or OZ. Clear? Now I'm making from this one end, find out or just draw the one vertical surface. Clear? Same from this corner as well as from this corner. So how it will look? By joining all those corresponding edges which are visible in the view. And this is the slant tapered surface I was talking, called as a chamfer. Now I'll erase this base reference so you can imagine how it will look in 3D. So completing this chamfer now, it's very simple. From the corner point, just mark given dimension as 15 on both the sides, so that it's easy to locate a chamfered surface, tapered surface. So complete this similar visibility, making a little bit dark. Same for this edge, which is also always visible here. Alright, so yes, first base, then this, then this. So we have completed 1, 2, 3 part. Then next, the last one, we have some rectangular surface which is a depth. It is not extruded, it is a in depth. You can see in the front view. So where it is located, it is, you can see the location is 20 mm from the end. From this 20 mm, this distance is 20 is given and dimension is 20 by 40. So very simple. And of course at the center of this, so first I can locate the center as I have already located here. This is 60, so this is somewhere 30, center of it. It's symmetric, so I always you find out the symmetric point for your reference. And then draw a center reference thin line for your reference. I'm just drawing this thing. So here is there somewhere center of this rectangular slot. It's not slot, it's a depth given to the object. Now where it is located, it is 20 mm from this 20. So here from this end take 20 mm point first. So that's the starting of this. This is H. What is this total? 40. So mark here again 40 mm from this. This is my 40 points. Okay. And now use your scale. And you need to draw. I'll take its center again to locate it correctly. So this is my 40 length. Center is 2. Draw a line parallel to this axis. Why you'll get to know soon. Now this is center of the rectangle. Why I've taken this 20 from here, it's 40. Find out center, draw a line parallel to this. Now it's very easy. From the center, locate the given dimension, which is total 20. So from center 1 centimeter. So here 10, here 10. That's it. Then draw all the line parallel, which are passing through these points, of course, which I have taken as a reference. Alright. The exact parallel line will give you the perfect visualization effect to your question solution. That's it. So then So I have created, then later you can make little bit thin all those reference line. You can keep as it is because actually they are a construction line, you should keep. So this is the surface. I'll make little bit visible. I don't know how the visibility is in the video, but I can't use sketch pen directly because there are many surface I need to erase later, so that you'll understand. And again I am using a basic steps from start to end, from box to again to draw a complete surface and then erase the lines, so that you'll understand. So yes, that's it. So what's left? The depth is 20. So very important. Why I'm taking this problem? First, to understand, there may be a question which can have a depth as well as addition or subtraction of the surfaces. Non-isometric lines means these lines are not parallel to any OX, OY, OZ, and the depth, how it can be represented. So if you see, the depth is sometimes you just draw a surface from this because you're looking from this, so this line is not visible, this is not visible. From any point there are three edges, right? So here it is non-visible, only this is visible, but we need to check the depth of the object. So I'll check with the trial. Yes, so total is 20. So if it is not cutting this line parallel, then we'll just have a continuous line like this. I'll make exactly vertical. Okay. Suppose that means there's a continuous surface, so the hollow portion below it, it's not visible. But if you mark 20 from that, and if it's somewhere here, then you need to draw one more line passing through that edge parallel to OX, OY or OZ. Check that. So it's for our understanding, I am making clear. So this is, let us consider total is 20 and it is not. So if it is like this, that's okay, done. But consider the depth is not to the up to this total height 20. If it is less, how it will look. So this is also complete solution, because if you check, this is exactly 20. So this is a complete solution. So this is what we are expecting. You should draw the object with the fine line work. I hope it is completely visible. Now let us consider we have a depth not completely this rectangular up to the 20. It is somewhere here. It is something like this of 10 mm. How the solution will change? I'll just make a slide. So I'll mark 10 mm height here. Then from that edge I'll mark the edges which are visible. So parallel to OX, similar parallel to this OY. And from that edge wherever it is, depends. So yes, so that is again one possible condition can be for this type of problem. So yes, now consider the height which is not complete depth. I'm explaining this addition part. Remember this, watch previous content. If it is missed, use something this. So if this surface is not up to this, if it's up to only this 10 mm, not 20. So this 10 mark here, from this edge 10, join parallel lines. Both. So once again I'll revise the surfaces. I'll make visible surfaces. So I think these lines are visible. So I'll just make sure you will visualize the surface. So this is a chamfered surface. So this dimension is not directly given, but total dimension is given, so you can find out. So from corner I have taken 15, 15 and I have joined this non-isometric surface. So not surface you can say, or lines. So this is 15, this is 15. One more thing, no need to give a dimension in the isometric views. You just mention the total length, total width and the total height of the object. Origin you can mention. It is not like your orthographic that all views should have that minimum these are dimension. So just If you draw correct view and the total length, width, height, it is quite sufficient. Now this is base plate with the chamfer. Now this surface is square of height. This height is 40 and square dimension is 30. So I'll make it visible, which lines are visible, which edges are visible. So this one, top face, all edges. These all are isometric lines, means they are parallel to OX or OY. Done. So this is a surface behind it, so it is nothing is visible here. Okay. This line visible. Slot of this dimension 20 by 40. Use drafter or roller at least if you have, and practice with the exact parallel line. I don't have anything with me right now. As you all know, we are going through most important thing of coronavirus of our life. Be safe, take care yourself, follow some instruction given by government. Okay, so this is a complete object which represent your isometric views. Now I hope it is clear how I have proceed to draw this object. Okay, so we started with this surface, this chamfer, this and this surface. So this is a very typical problem of orthographic isometric views. Orthographic, this is our orthographic projection, that's a question, and based on that we have drawn these views. If you guys have any problem, let me know in the chat section. I am checking right now, so I don't have there is any question from your side, so I'm just focusing now for the next question. So shall I proceed to the next question? So that's fine, we'll go to the next question. I hope it's clear. Please, if you understood this problem, thumbs up, make like, dislike, make your comment, feedback, so that I'll get some motivation and energy from you guys to proceed for the next sessions or to have good improvements, so that we can have a very positive and friendly discussion on this topic, because we both are at some important phase and quarantine at our location. So we are trying the best to use the resources and to learn all subject in best possible way. Fine. Okay, so let's start with the next question. Fine. Okay, so you see this second question. Let me clear focus if it is not. Yeah, but just a minute, it's interrupted the live, so I'm again reconnecting. Okay, fine. In the next question, look at the dimension given. This is a front view given, and this is a, of course, side view. So identify which side view it is. I'll mark here front view. So they have given it is front view. That's it. So either they mention the view names or origin position, either or. Minimum 2 views are required to understand any drawing, because One view explain only two dimension, either length, width, height, either of all those dimension. So now we will have a direct discussion on this topic, how to proceed with second question of orthographic spheres. So let me clear first what is addition, why I've taken this second problem. It's little bit of, it looks same as previous, but it is having a two interesting things. One is this lot, which is not rectangular, but it is a trapezium slot. How to construct trapezium in the ISO, it's very important because we cannot mark non-isometric surfaces or lines directly, or we can't take angle in between already. It's because it is a isometric surfaces or lines. So we can't take angle directly here. That's why we draw hexagon, pentagon first in 2D, then we transfer. Same logic for this. But as here we don't have given an angle, it's already given a dimension. So a little bit easy, but we are interested right now how to mark the trapezium here. Additional, very interesting, we are discussing today this part, circular feature. So if you observe it, I think it's clearly visible. It's a semicircle for this front view given. So trapezium, circular feature, that's it. That's two additional part we are going to learn right now. So try to imagine, I'll give you quick 2 seconds to think how this object will look. Can you think how this circular feature, where it is located, how it is located, and this. As this is front view, this position of side view will be, which side view it is? Of course, this is a left hand side view, because that is drawn on the this side, right side of front view. So as it is left hand side view, so this surface, this should be visible when you look from the left. I have drawn already this surface to save your time of this video discussion. So draw origin 30-degree lines to front view. So here front view, you can have front view here also, depends on question. So here left hand side view, so here is a left hand side view. So this dimension is, find out, total width 60, total length 100, and total height is 60. So the length, width, height is given as 100, 60, 60. Front view is visible here, means this surface is looking from this side, and the side view will look from this thing. So what do you think, how the circular feature will be visible? Think for a minute, because your imagination power should improve, or you should try to imagine step by step, so that in next session you can solve a highest difficult level problem. Okay, fine. So let's start. We will have a direct step-by-step discussion for this. So we'll start. I have drawn a block already. I'll just make sure that we explain the concept for the process for this. Draw horizontal origin, 30-degree lines both side. Length here because front view, left hand side. So from left, this is my left hand. So left hand side position should be from this, and this is 100 mm here. This is 60 as a width, so this is 60 here, 60. Height would be as given 60. So I have marked 60 from all the edges and completed the box. So this is isometric box. First step for reference, you always draw this box so that you will get an idea. So we'll start with this surface. So you can see clearly there is one plate of 20 by 100, which is similar to previous problem. So it is easy. I'll mark, I'll take a smaller scale first, mark 20 mm. How precisely you take all the lines, parallel lines and dimension. Accordingly, you'll get the superb and excellent solution. So complete this part first as previously drawn. So I'm drawing a little bit fast. So I'm completing complete surface of this. Here sometimes you make a mistake, you forget to draw this surface and then that's create problem. And parallel to this. Okay. So now this is a complete surface. You can see, I guess, clearly this surface and the top surface. Again, I am not here interested too much in the top surface because you can see here this. But for reference only, I'll keep these points so that you will get idea later. Now, I have drawn this L. So what do you think? Looking for front, this view as front, here is your front view X. L I have drawn this, sorry, not L, it's a simple base plate. And at center there is something, there is a straight surface up to this, okay? What is that? Logically, total 60. This is 20. What is the dimension of the circle? Diameter 60, so radius of course of the semicircle, radius would be 30, very logical. So this distance you can get from the construction very easily. So now 60 at the center of 100, so I need to construct semicircle. So interesting part this, how to draw a circle or semicircle, any part of circle in ISO that we already had in lecture number 1. So if you have any query, go and check lecture 1, how to draw a circle here. So I am locating this center and this positioning first. Remember, as discussed, to draw a circle in isometric, first condition, the dimension of the circle. So the diameter is equal to the square that we need to construct in the isometric first. So diameter is 60. So let's start. First locate the center, as a reference is a 10. So this is 5 mm center. Dimension is 60. That's the diameter I'm interested always for the circle in ISO. So from center 60 means I'll take 30 here, 30 here. So from 0, 1, 2, 3. Same 1, 2, 3, 30. Now construct a surface of 60 by 60 square at given position, means exactly at center, because this is at center, which is again vertical face. So I am creating vertical face. So I'll draw lines passing through it. I am drawing little bit dark because it should be visible in the video section. Later you just practice, see if it is not parallel, then it will create some problem later. Okay, I'll draw once again this line. So from this point, draw exactly vertical line to create a square of 60 by 60 square I need to construct. Alright, so if you check, I've drawn this is complete 60, this is 60. So consider total height of the block is already 60. If it is not, you can extend this, not this, because we know that this is the extreme height of the object, right? 60. So here is this complete end, this surface. Now what we do, how to draw a circle. This is the same line I'm extending. So construct, so now this is my reference square for drawing a semicircle. You may draw a circle for few objects. Here I am explaining semicircle. So this is a 60 by 60 square. We are going to construct semicircle here. Right. Find out the centers of all the. So I'll directly take a 30 mm distance in compass because I know the total is 60. So this is 30. So mark the midpoints of all the square. So this is 1, from this, and from this. So draw a square and find out the midpoint as 60 by 60. So what I did is just onto this surface, total, find out center, create 60 by 60 one square because the diameter of the circle is 60. Find out midpoint and join the two corners of diagonal opposite midpoint. So this is longer diagonal, we are not interested. Shorter diagonal is this, if you join this. So we are interested in these two corners. Join this diagonal with opposite midpoints, these two, and this corner with opposite midpoint, these two. This with these two. So from this I have done this. Please watch previous video if you have any doubt how to draw circle. Now I'll use again pencil, not directly sketch pen, to draw it, the complete circular feature. Later again I'll use it. So this end, these two ends as centers, and this V, these are the cross V's, are always formed when you draw a semicircular circle with the shorter diagonal. So these centers and radius equal to this V distance complete the arc, of course between the corresponding. So this center, this radius, again this center and this same radius, I'm going to draw this arc. Okay, so it should exactly be cut here. Same, from this compost leg you keep here another V end and join same, take the radius same, or this radius same, one and the same. But right now if you look at the question, this semicircle, we are not interested in this half portion, so I'm not going to draw this, right, only a half portion. Now this as a center, next intersection is this, two intersection of V, and so again small radius, so we'll keep this small radius here and we'll continue with this arc. So yes, this center, this radius, so mark this. So now this is complete semicircular feature. Now here you can see clearly this distance smaller is what this one is. Again you can check, this is this distance given. Okay, it's very logical. So later you can erase those construction. Actually you need not to erase construction and you have marks for this, but while drawing it, draw it faint. I'm drawing here a little bit dark to have a good clarity in the videos. I don't know if any problem in the focusing the content, please let me know in the chat. So I have constructed this semicircle by joining this cross V as a shorter diagonal, these two as a center and radius equal to same, we mark the arc. So this center, radius, this part, larger portion, smaller is with the smaller center and the smaller radius, this one. Not interested in the remaining half because we don't have the circle, we have only half, upper half portion is now interested. Okay, let me know, is it visible now? I'm using this as a focus point so that I'm not keeping this stable. Okay, thank you. Now I will again proceed to this. So yes, that's it. So I have constructed this plane surface of 60 by 60 exact location. This is extreme 60. So this sometimes it may happen your surface can go beyond this, depends on the dimension. So now I'll keep as it is all the point. Remember, I have used this center to draw this portion and this center to draw this portion. For this was radius complete, and for this was radius, smaller one. But this, we need to construct solid portion, right? Because it's a complete surface. If you see this side view, this is side view. So that's, if you see, this is a complete surface. There is no in between part like this. So this structure is throughout the width. So I need to give some solid structure for this. So again, another option is you can create same surface here backside and join it. But this is the simplest way. How you constructed this, just transfer those exactly parallel. So I have constructed this surface and transfer all the center and distances. So what I'll do is transfer this center to and corresponding point up to what? This total width, because this is solid object throughout width, right? So this is 60. So transfer this center along this width 60, this center along 60, and mark again same portion. So I'll draw a parallel line passing through the centers. So I have drawn this line. Again I have drawn this line. This is called as transferring the center or transferring the same object. Transfer centers 60 here, transfer this center 60 here. Take distance in compass, or directly you can mark here. This is width, so from this I have taken 60. So my new center is somewhere here. You can see here 60. So now new center transfer means I need not to construct again surface, again the V and all the stuff, just center. Same. Transfer 60 here on the parallel line of isometric box, means parallel to width, and it is somewhere here 60. So this is 60. So new centers, these two are centers. Now take compass, take a same radius which I have drawn for first day, this part. So this was a center, this was radius, right? This was complete radius which I have drawn this. Now same center is transfer 60 inside on the same parallel line. See, if the lines are not exact parallel, then it won't look like that 3D effect. Okay, yes. So center transfers on 60. Mark your same structure. Alright, don't draw complete semicircle, because one more is the smaller center and the radius, again you need to transfer, right? So now this smaller radius, another small center is here 60, and you take a radius exactly which I have drawn here, and new center, same radius, complete the small portion. Of course it is a small, yes, again don't complete, just a very small portion actually, it's not that here. Now yes, then draw a tangent, that's it. Tangent means exactly parallel to the width, as it's a surface. Okay, so yes, this latter you can erase this small portion. Yes, now the cylinder is completely transparent. So what I did, I transferred 60. Why 60? Total width is 60. If it is 20, somewhere a small portion up to 20, I can transfer up to 20 here. same radius, mark it. How I could run here this part, same, transfer 60, same radius, mark here. Done, that's it. Now what you need to do is you need to transfer this point again where the semicircle end, this point. So parallel to this, just for the convenient, yes, that's the point. Means here the semicircle ends, right? Then from it is a straight line, exactly. It's not up to the, so draw only this small vertical portion. Yes guys, done. So we are done with this most important portion, how to draw semicircle here, how it is transferred here by transferring the centers and distances. Now I'll erase major lines which is I have drawn for reference. Later you can, what I have transferred, I'll erase those lines. I'll make little bit the plane also little bit less visible so that you can have the visibility of the same. You can recap the video and again later can check how I have drawn the surface. Now to have a good visibility for this, of course you need not to do this thing in the exam. Once you draw, it should not be over it. Now, yeah, one more important thing. Which lines are visible here? This edge, of course, the complete this bottom surface or the edge. This line visible, no issue. But there is a surface, so there should not be line here. So this should be clear. So that's a semicircular structure. Now I'll draw a reference complete surface how it will look in the this side also. Okay, let me clear first this surface. If you have a little bit more length, so that can happen, that can extend, and you can see little bit portion like this also, like this side, what I have drawn. Now I'm interested to explain the last portion of this problem is very important as a trapezium slot. Guys, so how to draw the trapezium surface on this face, because if you see from left side this trapezium we are interested, so we are going to draw now trapezium here. Or to make it one more small correction that can happen actually, I am extending this surface to understand, because now this you understood, that's the visibility, or this is a solution. If I extend this line for let's say a 5 to 10 mm extra distance, how another possible case for this edge to be visible? Okay, I extend a little bit length on this side actually. It won't happen in exam, it's for your understanding purpose. Right now it is exactly coinciding that surface both. So yes, that can be. So always watch complete video lectures so that I'm explaining many tricks, twists in the same question. Yes, so that can be one possible view Now again here this surface is visible, so I'm going to draw this as a visible line. Okay, so this end and this end should match and it should be parallel. All right. Yes, now interested in the last portion, how to connect the trapezium surface here. Remember, sometimes they can give you the angle, this angle 60, this angle 30, whatever it is, this can be 30, anything. Okay, so now for the given question is I have taken simple, a trapezium slot is present here throughout, where dimension of 20, 40 and height, so directly all dimensions are given without angle, so very simple. But how to construct? First find out the mid of this, always to be symmetric here. So total 60, so somewhere here is 30, so here I am finding out center. 10, 10 from center, take here 10, 10. Is it visible? I'm explaining little bit small tricky part. How to construct trapezium? We don't have even an angle, so direct simple case, all dimension of trapezium slot 20, this 40, and where it is for this 40 at height 10. So here is the surface like this. So find out from center here, center of this here, there is no surface here. Okay, it's a slot. So center, this is 10 and this is 10, total 20. Now I will construct this center and this 20 and this 20. So I have constructed 2 points of 20 here. Now height is 10, but where to mark height? It should be on this surface reference. So I'll take 10 mm as a reference line here, draw parallel line to this width, draw line this. Again find out the center, or just transfer the same center on this line. This was the center, so just transfer here. Now at a height of 10, I have taken height, drawn parallel line, transfer the same center here. So again this is the center of the same. Take here 20, here 20, both side 20, because total is 40. I have found this at 10 mm height, center 20, 20. 9, sorry, from 0, 1, 2 mm, 2 centimeter, again here 10 and 20, 20 mm. So I got all the points. Join it. It won't look symmetric, okay, because it is already a 3-dimensional drawing. Many times students get confused, they draw direct here. When angle is given, you cannot take angle in isometric as it is. Remember always, if angle is given in question, this is 60-degree angle and 10 mm height. First you need to construct 2-dimensional trapezium slot with 60-degree angle and 10 mm height. Then take this measurement, all this, and mark here with the same procedure. That's it. Now parallel to this, draw one more edge passing through this, because as we discussed, 3 edges, always ensure. So yes, that's it. So that's complete object. Now what left is check all the edges if there is an extra visible, non-visible part. So I'll erase this line. So to quickly revise, I'll just make edges. One. Fine. Everything is now trying. So I'm making all these edges once again visible. So I have considered the first this trapezium. These are only visible edges, so later you can change. So why I've taken this problem, it has many features as semicircle, it has a trapezium slot. Again, important is we now studied how to transfer centers or any distances on any other plane. So it's just by transferring center and distances we discussed, and that is applicable for other surfaces too. Now to draw again semicircle, I need to use same procedure, or I'll freehand I'll draw, but better it's clearly visible, because otherwise I need to have same center and radius. I'll explain with the same process. So this was the center and cross V as radius. So I have joined. So this was first. Same center was transfer 60 mm here, and that was another, and the small portion was with this center with smaller radius. With sketch pen it's little bit tricky, or it's not that perfect, but if you draw on pencil and exact precise dimension, you'll get a nice and perfect view. Okay, fine. So this is what you can see. Yeah, same center, same radius. All right. Yeah, you can continue with this semicircle feature here also. This vertical portion small. This each. I hope that was this today's session, where we had two types of problem, and which covers a lot of concepts of trapezium slot, circular feature, as well as extruding and subtraction of two parts. So I think this was today's two problem, and it's quite okay, because as of this discussion on isometric views, a third lecture, if you are able to draw these problems finely and perfectly, as I'm not using a perfect drafter or roller, I'm using only scale and my skills to visualize you the same problem and explain you the concepts, it will surely help you. Okay, if you have any doubt, let me know. I'm checking the chat. Yeah, someone is asking me, is it visible now? Should I explain circle again? Okay. Any other part? Okay, I'll repeat the circle, no issues. But that's it, that was for today's. Once again, I'll repeat here, same surface, I'll repeat. So it's very simple, it's not that easy. I'll locate 60 by 60 vertical face. So I'll draw one vertical face here. So this is 60. Okay, first I'll construct a complete surface. So this is vertical, so of course I need to construct a line which are 30-degree inclined, right? So I'll try to take a reference from this. Okay. I'm constructing. It was interrupted, I was not knowing. Let's see, have you cleared with this? So let's stop this. If you have any doubt, watch previous lecture number 1, how to draw this circle. Just complete the same face, this as the center, longer as radius, again another center, smaller radius. Same with this also, longer shorter. That's it. I hope these two problems will help you further to understand isometric views and practice it. Be safe, take care of yourself, and try to draw all those problems with concept what we had in lectures. Thank you.